Welcome back to Eazy Algebra. Today's topic is polynomials and polynomial functions, and there's so much we can say about these. So we want to look at just the basic overview. So first of all, what is a polynomial? A polynomial is a type of function in which you have the form a n x to the n plus a n minus 1 x to the n minus 1 plus, and this pattern continues for some time until you get to lower values, like a3x cubed plus a2x squared plus a1x plus a0. All right, that should make things about as clear as mud. But let's take a look at this using a couple of numbers instead. So something you might be more familiar with would be a cubic function. So this is where the highest power would be 3. So let's say 4x cubed plus 3x squared minus x plus 2. This is one polynomial, and it's in the cubic family of polynomials. So we go back and look at our generic equation here. The reason that we use n here is that we want to identify any polynomial. And this number could be as high as you want. It could be 3, 4, 5, 6, 7, 8, 9, 10. It could be 127. And it would still be a polynomial. The reason we have a to the n is that a is just the coefficient. So we just say this is the nth term of the polynomial. This is the n minus 1 term. This would be the third term, the second term, the first term, and the constant term. So when you're looking at a polynomial, that's the way that they're structured. Polynomial functions are simply functions that take this form. We do many things with polynomials, but two of the important concepts that we need to remember are what it means to be closed under addition and what it means to be closed under multiplication. So if you think back to when you first started mathematics, you learned addition and multiplication of whole numbers. If you add two whole numbers, you get a whole number. If you multiply two whole numbers, you get a whole number. That's what it means to be closed. Polynomials are closed under addition, and they're closed under multiplication. So that means if you add two polynomials, you'll get a polynomial. And if you multiply two polynomials, you'll get a polynomial. Polynomials are not closed under a division. And again, that's very similar to how you experienced with whole numbers. Whole numbers were closed under addition and multiplication, but not division. If you divide two whole numbers, you could get something that's a fraction. For example, 2 divided by 3 is 2/3. So when you multiply a polynomial, in this case a binomial, times another polynomial, in this case a trinomial, you need to multiply every term by every term. There are several ways we can organize our work. One way is to draw lines. So I can show this is being multiplied by this, and by this. Well, this will be multiplied by this, and by this. 2x times x squared is 2x cubed. 2x times 4x is 8x squared. 2x times 5 is 10x. Negative 3 times x squared is negative 3x squared. Negative 3 times 4 is minus 12x. Negative 3 times 5 is negative 15. Now we can add like terms. There's only one x cubed, but there are two x squared values. And there are two x values. So we get 2x cubed plus 5x squared minus 2x minus 15. That's one way to organize our work. And that's often the preferred method for students who feel fluent in this sort of multiplication. Another method that takes up a little more space but can help students who struggle is to use a generic rectangle. So we set up our rectangle, split it into parts that match the number of terms in each polynomial. So my binomial here, of course, has 2 terms. So I have 2 boxes high to represent the binomial, and 3 boxes long to represent the trinomial. My binomial's terms are 2x and -3. My trinomial's terms are x squared plus 4x plus 5. This helps me to lay out my multiplication. Multiply in each box. So this box here represents x squared times 2x. The first box is going to be 2x times x squared, or 2x cubed. The second box will be 2x times 4x, or 8x squared. And the third box will be 2x times 5, or 10x. Moving into the second row, the next box will be -3 times x squared, or -3x squared. The next will be -3 times 4x, or -12x. And the last will be -3 times 5, or -15. Once again, we can look at our like terms. We have 2x squared terms, and we have 2x terms. If you compare this to what we had before, you can see that everything lays out the same, even in the same order, but that the organizational method is different. Our answer will, of course, be exactly the same. The second type of problem we want to look at is evaluating a polynomial. There are actually a couple of ways to evaluate polynomials. One of them is simply by plugging things in and following the order of operations. So we'll run through that first as our baseline. We'll plug in -2, and we'll get -2 cubed plus 4 times -2 squared plus -2 plus 6. So now we can start running through the order of operations. We don't have any groupings, but we do have some exponents, so we'll do those first. -2 cubed is -8, plus 4 times -2 squared is 4, plus -2 plus 6. So now we can do our multiplications. We have -8 plus 16 minus 2 plus 6. So now, finally, we can start adding. -8 plus 16 is 8. 8 minus 2 is 6, and 6 plus 6 is 12. Therefore, the value of our function when x is -2 is 12, or p at -2 is 12. So there's our baseline. We know the answer. That method works decently well. There's nothing wrong with it. The risk involved is as the polynomials get larger, the work and the chance of making small errors increases. So let's look at another method using synthetic division. To synthetically divide, we would simply set up -2 and we take only the coefficients. So the coefficient of x cubed is 1. The coefficient of 4x squared is 4. The coefficient of x is 1. And the coefficient of 6 is 6. We bring our first value down, and then we multiply. -2 times 1 is -2. 4 minus 2 is 2. 2 times negative 2 is negative 4. 1 minus 4 is negative 3. Negative 2 times negative 3 is positive 6. And 6 plus 6 is 12. Notice the similarity here. 12 is our answer here, and 12 is our remainder from synthetic division. The remainder of a synthetic division problem is also the evaluated value of a function. So this is a second way that we can evaluate the value p of negative 2.